So it'll be kind of interesting. Like all these labs, some of them I've kind of done a little bit before. This one, I just know that I have the chemicals we need. There's a difference, I won't even say it's a subtle difference, between fats and oils. Basically, fats are solids as far as I can tell, and oils at room temperatures, they glob together, and oils are liquids. Okay? But what they both seem to be are kind of greasy, slippery, soft, low melting point, and they don't dissolve in water. Why would that be? Well, water is polar, so actually these are non-polar. Your fats and your oils are non-polar. Things that we eat, including butter, cheese, cream, whole milk, and meats, have fat in them. These actually, as I've kind of listed here, come from animal origins, but there are definitely some things from not animal origins, from plant origins, that fall into this category. Okay, we have a lot of oils that are from corn oils, say soybean oil. We have a lot of oils. Olive oil come from plants. Going to talk a little bit about the chemistry of them. So you're going to need to kind of recognize, well, what's it made of. And it actually starts with a tri, meaning 3, glyceride. And the triglyceride itself has 3 of these ester functional groups.
So it's an ester functional group of glyceride?
An ester functional group down here is a piece that takes 3 of these glycerides, or esters, to make a triglyceride.
Let's buy that second one.
What's that?
Buy.
The bi, the what?
I think it's like a little.
Oh, this? Yeah, it's a little dash. And it's used prime, the word prime. So this would be R, and this would be R prime. So R and R prime, and it just means that it could be anything. It's just saying kind of, but what's important about an ester group is you have a carbon, double bond oxygen, and that same carbon is also bonded to an oxygen. That's what makes it an ester group. So triglycerides, okay, look for this ester group, 3 of these ester groups coming up, okay? So fats are solid at room temperature and oils are liquid at room temperature. They're both triglycerides. I'll try to convince you what a triglyceride is. Triglycerides are a subgroup of lipids, L-I-P-D, lipid. So lipids can be things other than triglycerides. Also in the lipid family, cholesterols and steroids. So we have this kind of logic tree up here. The top is lipids, and then from the lipids, we have triglycerides, and from the triglycerides, we have fats and oils. So that's kind of the overall arching thing. So let's see what we think about this little video. These videos were fun to pick out, by the way. Number goes there. Triglycerides are formed from the reaction between how many fatty acids? 3. 3 fatty acids, and the alcohol, glycerol.
So, is that what the word glyceride is?
Glycerol would be that carbon. It's a tri-alcohol. Glycerol is just the kind of the hub. You know what I'm saying?
But is it a glyceride if it's the fatty acid in the
So you take the glycerol molecule, and then you attach 3 fatty acids, and you make a triglyceride. The triglyceride has the fatty acids, and then the triglycerol are the glycerol would be the 3. There's no tri with it, but it's 3. You know what I'm saying? Mm-hmm. Cool. I have another video to show you about fatty acids. Fatty acids are so awesome. It's even more awesome than cations and anions, and going and taking a cation and an anion and making an ionic compound. It's kind of like you saw in the video. You get to go to your cabinet and grab 3 fatty acids, stick them, and make a triglyceride, and you get a different triglyceride with the 3 different fatty acids. So they're generally, they can have 12 to 24 carbons. Okay. We called it an ester group a minute ago. The difference between an ester and a carboxylic acid are this. So an ester, remember the R and R prime? In that case, think of taking one of the R's and making a hydrogen. And there you have a carboxylic acid. So, you guys see that marker? That's what I did for just walking away. Okay. So, carbon, double bond oxygen, single bond oxygen, R, and R prime. So that's an ester where these things can be anything. And if we go ahead and make one of those things a hydrogen, okay, that makes it a carboxylic acid. Okay, so that's how that goes. All right, so here are some different ways of showing these fatty acids. But what they have in common is that kind of this one has a carboxylic acid sort of group, where C, double bond oxygen, OH. And that's when the video that's what they showed. Okay, this one's even a little more clear. These are all the same formula. I mean, they're the same fatty acid. So if you were to take these CH2s, combine them together, you get 16 of them. And so here's your 16 all grouped together to make, let's see, where does it start? Yeah, because it was there. To make this quantity 16. And then the other thing, and again, it's like a chemistry thing, but you got to realize if you see something with these squiggle marks like this, it's like I've been saying, you have to picture a carbon at each end of the little segment. So we have a carbon at the end. You have a carbon here, a carbon here, carbon here, carbon here. Okay, you have to, in your own mind, unpack that. And then at each carbon, you have to remember or think of, they're counting on you, thinking of, well, it's going to join to 4 things. And if this carbon on the end is only joined to another carbon, and the things it's going to bond to are hydrogens, unless they show you, I need to have 3 more hydrogens there. So each time I put a dash, that's a hydrogen. So this group is this group. Okay? And then you can kind of see the carboxylic acid here, where at the center is another carbon atom. It's just shorthand. So those are just different ways to draw that same fatty acid. And here's another way to show that fatty acid. This is a good way, isn't it? The black balls are the carbon atoms, the white balls are the hydrogens, and the red balls, of course, are your oxygens. All showing the same fatty acid. Oops. That's easy. Okay, triglycerides start with glycerol. I'm kind of talking for me and for you. And glycerol is kind of that hub. And glycerol looks like that. It has, this has OH. It's like a tri-alcohol. Okay, that's glycerol. Just itching to go ahead and connect to 3 fatty acids. Okay. I have some other things to kind of show you what glycerol looks like. So these are different ways to look at glycerol. What I drew on the board is this. glycerol. Again, it's a hub, just ready to go ahead and connect to 3 fatty acids. These mean the same thing. And then this one's the most confusing to me. I'm like, are you serious? I remember that whenever you see kind of the end of a line like that, I think if I tap like this, yeah. Okay, I could put a carbon here. Oops, I can't draw on it while it's up here. But I could carbon each one of those vertices. So I put a carbon here, and a carbon here. And then again, you have to make up hydrogens. Okay, so if a hydrogen is connected with an OH we call hydroxyl group, then it needs the ones on the end it's connected one there and one to a carbon, it needs 2 more hydrogens. Okay, 2 more hydrogens to make it up. So different ways. The last one's my least favorite. Here is the ball and stick. Again, the carbons are the black atoms, the hydrogens are the white ones, and the oxygens are the red ones. All right.
It seems like, if you just read it anyway. Or
I don't know. Which way? What?
I don't know. It just seems like we don't have like a formula for any of those except for maybe the structural one.
This one?
Yeah.
This is the way, I don't know if this is what you're saying, this is the way I think of it. But maybe if you're in the biz, you kind of get like, there are advantages to these other ways of saying the same thing. So here we go. If we have the formation of triglyceride coming from 3 fatty acids that are all stearic acid and 1 glycerol molecule. So this guy right here, this is your stearic acid. Okay, does it look like a stearic acid? Well, I can see actually the carbon chain has 16 plus 1 plus 1. It's like that 18 carbons. Okay, this is my carboxylic acid group. That's going to help with what we call the condensation. So it takes 3 of those, 1 of these, and I know that it looks weird, but this is your glycerol. And then what's going to happen is that for each one of these 3, the carbon is going to go ahead and connect. How's that work? It's going to take this oxygen and hydrogen and that hydrogen out, and that carbon's going to stick right there. So basically this carbon is going to stick right there, and oops, I did that wrong. This carbon is going to stick on that oxygen, final answer, not that, on that oxygen, and that hydrogen and this hydroxyl group is going to go away. So on the product side, you're going to see H2O, and that's what goes away. Sorry about that. So on the product side, you're going to get 3 waters that go. And can you see kind of the one that I showed? This carbon could be this carbon right here. That's this, yeah, this carbon right. Check that. This carbon right here, okay. Single bonded to an oxygen, and then this is the fatty acid. Okay, and this was part of the glycerol. And it does that 3 times. So the video we watched was kind of like the 3 little baby fingers. Okay, those are your 3. And remember that when you have a bunch of carbon and hydrogen like this on the fingers, okay, that's nonpolar. It doesn't like to dissolve in water. All right. See, no links there. I have a link coming up here. I know we've talked a lot in our videos about saturated and unsaturated, but we'll go ahead and see this. Okay, so saturated fatty acids, and sometimes, I don't do a lot with this topic, so I have to concentrate. Saturated means it's saturated with what? Well, it's saturated with hydrogen. Saturated means saturated with hydrogen. And if it's saturated with hydrogen, then it means that there are only single bonds. Okay? So if it's unsaturated, that means it doesn't have all the hydrogen it should. And if it doesn't have all the hydrogen it should, then it's going to have to double bond to one of its carbon buddies. So you'll have at least one carbon-to-carbon double bond. So here are some examples. And again, and I guess I got to stop apologizing. This sort of structure is that the condensed formula. I think I'm saying, or the line formula, I guess I should say. So you have to unpack it. So at the end, you have to put a carbon, and at each of the little connectors, you have to put carbons, and you have to do makeup carbons. That's funny. I made that up. Okay. So we have a, there's your carbon chain. Of course, here we see the double bond that makes it unsaturated, right? I learned something, I'm continuing to learn something. They talked about the omega 3, 5, and 7. Let's see what we think. If this is carbon number 1, okay, carbon number 2, 3, 4, 5, 6, 7. That looks 8 to me. 1, 2, 3, 4, 5, 6, 7, 8. Well, it's 9. Was there a 3, 5, 7, 9?
3, 6, 7, 9.
Okay, good. Final answer. I'm like a 9 for this one. So that would be an omega 9. Here's another one that's unsaturated. Okay, again, double bond, unsaturated with regard to hydrogens. So we're looking 1, 2, 3, 4, 5. This looks like 6 to me. There wasn't a 6 one, was there? But it's polyunsaturated instead of monounsaturated, so maybe that's the difference. So these are fatty acids. This one is, and you're going to see, you're going to see both of these. I have a pet peeve, okay? Check this out. Do these both look like the same word to you? They totally look like the same word to me. They are different. Oh, are you serious? And here in a minute, these guys are important. They're going to come up as a topic because our bodies, how does this work? Our bodies can make fatty acids, a lot of different fatty acids, but they can't make these. So we have to get these from outside sources. Linoleic and linolenic. I'm sorry, that's just too close for me. Let's see what the video says. So we have to adjust those. I mean, compare that to in meteorology or in... So again, I get excited now about fatty acids because fatty acids, you get to pick 3 fatty acids, stick them together with a glycerol, and you get to make a triglyceride, which is a fat, right? So that's kind of fun.
So what are foods that are high in trans fats?
I think I have a video on that. What are foods that are high in trans fats? Yeah, that's coming up. So these would be the building blocks of fats. Fatty acids are the building blocks of fats. So these, you can kind of see them increasing. These are the naturally occurring ones. The bottom is synthetic. So you can see them increasing in the number of carbons in their chain. And then we talked about this, that actually, as you increase carbons, you should increase those what we call van der Waals forces, and you should have a higher melting point. And so we do.
So what's gluten? I was talking about gluten. What's gluten?
Gluten? I think that's coming up too. I think a gluten is a type of starch, so it's coming up. Yeah, it's coming up. Hold that thought. So I guess I was wrong. I was thinking of sweeteners. These are both naturally occurring, but you can see that these are saturated. Notice no double bonds, and these are unsaturated. And these guys down here are the bane of my existence, linoleic and linolenic. Linolenic. Oh, gosh. They both have 18 carbons, but one has, the one with the 2 ends actually has 3 double bonds. Oh, did you not have this? Sorry, I didn't do that.
There's a lot of things that I wish you hadn't taken that out because it's like you can't draw it. You don't have time.
Okay, I will. Yeah, I usually fix that before. I didn't fix that before I came. So thanks. Next time, be sure to mention that because that's not my intent. It just I wanted to emphasize it, and so I covered it. But I usually uncover it before I send those. But alas, I did not.
I tried as well.
That looks pretty good, though, actually.
I gave up on this one.
Yeah, I'll blueprint those. So the ones that I left up. Well, then here is part 2. All right. So continuing on with that discussion. So the word is synthesize. Our bodies can synthesize most any fatty acid from the foods that we eat. Is that not amazing or what? Things we can't synthesize are those 2 annoying ones that start with the letter L. Linoleic and linolenic. Well, maybe it grows on your acids, which must be present in our diets. And I have a video to show you about that. So here's a list of different oils and ending with, I guess they're all oils, or chicken fat, okay? Oils and fats. The color-coded goes this way. We have saturated. By the way, unsaturated is not bad. It's the unsaturated trans that's bad. So we have saturated, monosaturated in yellow, a source of linoleic acid in red, and we kind of have in green, we have that alpha linolenic acid. So the last 2 are the acids that we can't synthesize. Flaxseed oil is rich in linoleic. The second one, sunflower, corn, sesame, soybean oils are good for the first one. Now remember the difference we saw on the last slide of part 1 is that we have 2 double bonds in the linoleic and 3 double bonds in the linolenic. Palm kernel, okay, I just have some, looks like I have more saturated, the word is saturated there. You can see that with regard to kind of the yellow, that these guys up here, we have a lot of yellow, a lot of saturated, monosaturated, contain more saturated, well, I guess it's saying, I guess that makes sense. I'll buy it, it's just interpreting this. The palm kernel is down here. All right, I get it. Palm kernel's down here. We have a lot of blue, and the blue is the saturated. Okay, so let's see about the diets thing. Let's get some place to stop, I think. We'll pick up here with the hydrogenation, just adding hydrogen to unsaturated fats on Wednesday. But don't forget about lab tomorrow. So.